I'm delighted to welcome Harry Shum, Vice President for Core Search Development at Microsoft, as today's speaker in our first View from the Top of the spring semester. As you folks know, the View from the Top gives the college community a chance to hear from the best of today's business leaders and technology visionaries. I'd like to thank the Berkeley chapter of SWE, Society for Women Engineers, for co-sponsoring today's lecture. Thank you, SWE. Before I introduce Harry Shum, I'd like to invite you to mark your calendars for two additional special events coming to the college. On Thursday, March 14th, we will celebrate the second annual Ernest S. Koo Distinguished Lecture with our special guest, William Sullivan, CEO of Agilent. And Bill's topic is why the century of biology is great for engineering. And he gives a great talk on how a lot of what happens at Agilent, which, by the way, is doing really well, is really built around systems and synthetic biology and instrumentation and all of that. So it's going to be a fantastic talk, and I hope you'll join us. And that lecture will be here March 14th at 3 o'clock in the Banatao Auditorium. Then on Monday, April 22nd, we'll welcome Leah Jameson, who is the Dean of Engineering at Purdue, as our inaugural Minner Distinguished Lecturer in Engineering Ethics. That lecture series brings global citizens to Berkeley to share their insights on the ethical, professional, and social responsibilities of engineers. Leah has had an exemplary record in connecting engineering students with high-impact community service projects, and we are really thrilled to have her launch this new lecture series. That will be Monday, April 22nd at 4 p.m. in the Sibley Auditorium, and that's for the Minner Distinguished Lecture. And of course, all of this and other events are on our website, coe.berkeley.edu. Now, let me do the formal introduction of our speaker. He's an old friend, and I'm delighted to have him here. So Harry is the Corporate Vice President responsible for Search Product Development, that's Bing, at Microsoft Corporation. Previously, he oversaw research activities at Microsoft Research Asia and the lab's collaboration with universities in the Asia-Pacific region. He was responsible for the Internet Services Research Center, an applied research organization dedicated to long-term and short-term technology investments in search and advertising at Microsoft. In terms of his background, he joined Microsoft in 1996 as a researcher based in Redmond, Washington. He moved to Beijing as one of the founding members of Microsoft Research China, later renamed Microsoft Research Asia. There he began a 9-year tenure as a research manager, subsequently moving on to becoming the Assistant Managing Director and Managing Director of Microsoft Research Asia, Distinguished Engineer, and Corporate Vice President. Harry is an IEEE and an ACM Fellow, and he was elected Fellow, recognizing his contributions to computer vision and computer graphics. He received a doctorate in robotics from the School of Computer Science at Carnegie Mellon University. Please give a warm welcome to our speaker, Harry Shum.
Thank you very much, Dean Sastry. It's really a great pleasure to be back here, and thank you very much for your time. So I hope I can do an entertaining presentation to you, not just that, providing the free lunch to you. I also want to particularly thank the Women's Engineering Society for co-sponsoring this talk. At Microsoft, we take diversity very seriously, and I personally spend a lot of time recruiting and mentoring women engineers. And this fiscal year, I actually sponsor 2 women engineers in the company. It's very difficult to really get a lot of women engineers into our workforce. It's actually very important and healthy to have a lot of women engineers in our industry. So I hope more women engineers from Berkeley will apply Microsoft and work at Microsoft. My talk today is called the Bing Dialogue Model. It's really sort of a reflection of a lot of things that I have personally worked on with my team in Bing in the last several years. really going after, what are the most important things now in the search industry, and what's next, and in addition to where we are today. So before I get into the technical details, I do want to take a minute to reflect a little bit that my own career and going to a product team from a researcher. And I was a researcher, as Dean Sastry said. I was a researcher for 11 years in Microsoft Research. And then I actually was assigned to join the product team initially as the chief scientist. Then I took the entire engineering team. It's certainly a shock to me, initially. And really, if you think about the difference between research and the product, it's almost the opposite. In research, that we really encourage the uncertainty. We really encourage, let's just say, that everything we do in research is actually something that no one has done before. But the engineering team, to build a product, not only that you need innovation, a significant part of that, I would even argue that the majority part of that is actually eliminated the uncertainty at the time you actually build something. So it took me a while to really get into these different modes. And I have been in Bing team for 6 years. And I'd be happy to answer some of the questions in case you have, as you think about, after you graduate and getting into workforce. So I want to sort of, remind people, why we are in this very important competition, and as we have very good product and the service in Google, and why we actually still need Bing. But before I do that, and I do want to do a very informal poll. And how many of you in the audience actually have ever heard about the Bing? Oh my goodness. Whew. Wow. So how many of you have ever used the Bing? Berkeley is great. So far so good. How many of you use Bing regularly? Oh my goodness. At least Dave uses it. He's our advisor. So I try again. Seriously, how many of you use Bing regularly? I make sure that they get your name and send you Bing T-shirts. And now those students really regret that they didn't at least pretend. And I really enjoyed my graduate student life in Carnegie Mellon. And even as I see the free food, it really reminded me of my graduate student days. I often joked that for graduate students, I assume undergrads are the same. For students, there are only two things you need to provide to them. I really refer to boys, and free food and the free T-shirt. And you don't even need to give them pens. So before, I just want to sort of level set how difficult how challenging the situation was. Ever since Google happened, and no one took share from Google. And it's just very, very difficult to. Not only that no one was able to take share from Google, Google was eating everyone's lunch. And initially, if you look at that, Google, of course, happened way before 2005. If you look at this chart, from 2005 until 2009, when we launched Bing, and Google was just like this, and for good reasons. The product was really good, and service was good. And then you look at the Yahoo and the Microsoft. At that time, it was called MSN Search, and just constantly going down. So the trend was very, very clear. It was very difficult, to compete with Google. And we actually talked to a lot of people. Why is that? And there are a lot of the industry experts. And one person I often enjoy talking to is Danny Sullivan. And Danny actually runs this website called searchengineland.com. If you're interested in search engine, the general information about the search engine, I highly recommend his website. So we actually invited Danny to come up to Redmond a couple of times talking to him. And he always questions Steve Ballmer's determination of really building the search engine right. And he actually challenged us that. He said that you guys have to realize that by now, it was already quite a few years ago. He said by now, Google has become a brand. It's actually not only a brand. He said Google is almost like a habit like smoking cigarettes. So I just want to remind everyone, and as you continue to use Google, you just have to realize that it's kind of like you keep smoking, and it's really not good for your health. And And the Bing is much more healthy. And I often remind the people that we have so many problems, environmental problems, because Google just uses so many goddamn servers. And they burn the coal and sort of, you got my point. And at the same time, I have huge respect for the boys and girls in Mountain View, and they have done a fantastic job. Many of them, of course, graduated from this very university here. They're trained by Dave and those guys here, and they cannot be that bad. So really good. So we actually compete with them, feel just really very, very difficult competition overall. So I want to just roll a video and just to show that how difficult really it has become. And it's really not only a technology competition that I will talk about the rest of my talk, but it's really becoming a brand. So let's roll the video.
Search, the final frontier. This was the challenge for our enterprise. Our multi-year mission to give us new life and new monetization. To boldly go where someone had gone before. The year was 2003. There was a new product coming down the pike. What it needed was a bold new name. Yeah, that's probably not it. So, we tried again in 2005. We put the best minds in the business on it. Nope, not quite. Okay. That'll do for now. In 2007, we decided to really focus on creating a breakthrough name. We asked consumers what they thought, and they told us. And so it was, with great confidence and optimism for the future, we prepared to unveil this new brand in the spring of 2008. God! All right, then we got serious. We double and triple checked with customers. We wanted a name that spoke to the aha moment. It was like the cherry on top of a great new experience. That was classic, timely, that was the sound of found. Nope. Nah. What? Come on. Bing!
Bing! Bing! Bada bing!
That's it. That was easy. Bing!
I already made up my mind that when I'm done with programming, and I should just jump to the marketing department. It's a lot of fun, creating this kind of videos. A lot of people ask me why we actually named the search engine Bing. There are many, many stories, and if we have time, I can share a few with you. But here's the conspiracy theory behind the name of Bing. I think with the popularity of search engine, I think people, including those smart people in Berkeley, are eventually becoming lazy and lazier. And we will forget about a lot of things. We used to remember, for example, hundreds of phone numbers. Now I can hardly remember my wife's. So I think it's just getting to the point that we keep forgetting things. And the theory I have is actually, as time goes on and the people will forget about anything, like say 6-character words. And in the end, they can only remember 4-character words. And then the search engine we build will just win. So, and I hope you get the joke. So, there are many other theories, and people hypothesize like Bing, Bing is not Google. So that's one thing. And the internal joke is actually we say Bill is not gone. So So what we really have done, since for the last several years is first of all, if we want to build a credible search engine, the search quality has to meet the bar. And not to mention that there's a very strong competitor out there, and the search quality is good. And the funny thing is actually search quality is something that keeps moving. And no one really knows what should be really the bar for search quality and out there. And if you really think about that, it's kind of funny that the search engine never really promised you that you will get the right answer. Never. It just never promised you. And what it does is actually kind of like, yesterday afternoon I was talking to Professor Stoika, and it's kind of like error-bounded computation. And they just say, we present you something with a lot of errors there. But trust us, it's somewhat relevant. And you know what? you cannot really get anything better if you don't use our search engine. So I think there's something there you should really think about. The way we define the search quality, there are really three different parts. It's really the relevance. You give the search engine a few words and a query, and you get something back, and mostly in the form of all the documents. And you need to get these results really fast. And let's say in the order of a second or so. And there is a very nice study by Akamai, actually. It showed that any website, if you go there, get some results, if it's beyond 2 seconds, people tend to leave. So that's the performance part. But this really goes beyond just to get the search result page. Hopefully I get to this point later. And the last one is actually, it's a consumer product. So you want to fasten through it. You want to have this very nice user experience so you actually enjoy using this product. And, but the first and the foremost is really, say, the relevance. You type a query, you think what you're looking for. So we have come a long way since we launched Bing roughly about 3.5 years ago. And at the time we launched Bing, we had only 8% of query share left in the United States. And in the US, since the launch, we have really gained the unique users, more than 45%. And the market share now, we actually have grown from 8 points to 6.5%. The last month's ComScore data showed that. And we also power Yahoo search backend. We actually did a good deal with Yahoo. And so Yahoo now still has roughly about 12-13% of the query share in the United States. In the previous video, it was a kind of hidden joke there when we were thinking about relaunch the Bing brand, the search brand. We almost launched as Yahoo brand because we actually proposed to buy Yahoo, and it didn't work out. And it was very close. So with Yahoo, we actually have 28.5%. And also the awareness. I asked you that without any prompting, that do you know there's a product out there called Bing. Turns out that in the United States, 71% of people, anyone on the street you ask, and they actually have heard about Bing. So it's actually becoming a pretty strong consumer brand. And the search quality is really something that people start to recognize. And I mentioned about Danny, and I still talk to Danny from time to time, and he often told me that by now the search quality is no longer the biggest problem, that he's not using Bing very often, and he's using a MacBook, and then he installed Chrome, and he just try queries there, and by default he's using Google, so that's a problem for us. But he's saying that Google is not always better if you look at the search results, and there are many other publications in our industry. And there's this one I like most is the article called "The Fallacy of the Superior Search Engine." It's basically saying the Google nowadays is still a very good product, but if you have a chance to really try Bing and Google, you might arrive at the conclusion that two search engines are very, very comparable. So we launched a marketing campaign. It's called bingiton.com. If you go to bingiton.com, you can look at the side-by-side comparison and try it for yourself. Hopefully, you will be pleasantly surprised and give Bing a try. So it's still very, very difficult competition, make no mistake. But we actually try pretty hard. Search today is still a very difficult problem. And it's really amazing how far search has really improved. It starts with people try different queries, and they actually try random things. And many people actually mistype or type the wrong things. And by now, because search engine has become so powerful, and the people actually have high expectations, but it's really hard. And we were trying this query, say the Berkeley new chancellor, and they try Robert Berkeley. And English is not my first language, so I really don't know how to spell. If you look at that today, you try on Bing, and we actually didn't get it. I assume that, because I tried this query and I want to look for, Berkeley chancellor, and they didn't get that. And then you try on Google, and so this one we actually didn't. And this is a recourse link. We said, well, we think you're probably not looking for this one. We actually tried to change the name to Robert Brigandy, and it's not really what I was looking for. Now, if you try on Google today, and Google actually does really well, and then you say, wow, it's really magic. Really, you can correct that. This really called the speller. The query speller actually gives you this thing. And indeed, very often that you try different search engine. But that's my point. My point is that if you try a different query, and let's say someone is looking for nicotine withdrawal, and you mistype this way, and Bing actually gets it. If you look at Google, and Google actually suggests a different way. And so it's still very, very hard. And by no means I'm saying that the Bing is already miles ahead of our competition. I'm just merely suggesting that very often you try on one search engine, and if you don't get the result you're looking for, and keep in mind that you can still try the alternative, and give Bing a try, and again, it might surprise you pleasantly. So that's actually starting with the query coming in. This is actually a hard problem. So I want to argue that what we are doing here in terms of web search is that we're really at this point that the whole search paradigm is actually changing. It's really changing from what I call as the traditional hit or miss model to more and more dialogue model. Recognizing that search is such an inherently difficult problem and the ill-defined problem, there's no one-step solution here. The right way to think about this problem, especially to design the product, is actually think about the dialogue and give the user a chance and give yourself a chance to continue the dialogue. So with that in mind, what's really happening here is actually the first thing is actually we actually moving from traditional lexicon indexing and matching to more and more knowledge computing and the contextual intended matching. It's not just say literally you type some query and the words here just to say matching those words. Then you start to really understand that what's really behind those words. Are there some concepts there? Are there some entities there? So are there some knowledge behind that as we get more and more queries and we use search engine more and more? The second thing is actually, until now, the interaction is actually mostly, you try to pull something from the search engine. And the interaction needs to be changed. More and more, it becomes more proactive, interaction, both push and pull. And not only you want to, give the search engine a few words and pull some information out, the search engine try to understand better what you are really trying to do and push some stuff to you as well. And that really means that the problem is changing, from the current problem is actually the relevance of the web documents or the URLs, gradually changing to it's really more and more the user intent, especially, approximated by the entities. And I will show you some results very quickly. So it's really becoming this relevance of URL and the entities from the traditional just document matching. What it really means is actually the user intent. It's basically saying previously, mathematically, the problem can be formulated, say, minimizing the time between the URL and the query matching. So you match the query and the URL, and you try to come up with 10 best results. You do that really, really quickly. So that's actually what we have been optimizing until now. From now on, my view is we really need to minimize the time or the effort to completing the task in the user's mind. It's not a single query, get some result, and you're gone. It's really about you have something, whether it's planning a trip to Seattle, or buying tickets to some concert, or something that in your mind, you start with a query, and you continue to get the next query. So the problem is really you try to design the product, say, well, maybe the right way to think about completing the task fast is suggesting a few queries that the user can really finish the task much faster. So that is the direction we want to go, and it has a lot of implication of how we actually design the product. So I will take you through some of the steps how we're actually thinking about this. So I put this slide here is mostly for Dean Sastry because I was told that you cannot come here give a talk without at least one slide with equations. It doesn't really look like an equation. You just have some very simple formulas there. But hopefully I take you through this, and I promise this really is the only slide with equations, and I take you through that and slowly and it really says how we think about the product. If you think about the product, the overall the dialogue, there are really 3 loops here. And I did not draw the out loop. So I will focus on really 2 loops here. And one is really the intent, the other one is really the knowledge. So what's really happening here is actually you design the product feature here. Then you actually have some expectation. You have some expectation. Let's say you come up with 10 search results, 10 documents. You really want those documents on top get clicked more than those documents at the bottom. It's very simple. So that's actually your expected behavior. And then you go through this intent model, and they say, well, the reason I actually understand that is because I actually have the algorithm to rank those things. Then you go through the interaction model, and you say, well, I allow the user to click. So users can click, for example. You can browse and click. Then you actually record these things, and you go feedback, and you come back, you say, is this right? What if I actually have this number 3 results often clicked more than number 1? Should I change? Now you really have the choice. And you may or may not want to change too fast, because you also want, at the same time, have some kind of consistency. And for example, so Wikipedia has been regarded as a site with certain authority. Sometimes even the clicks, the first result, say Wikipedia versus the second result, even if the second result clicks slightly more than the Wikipedia, you may or may not want to change it too quickly. So this is really the main loop. You design the product, and that is actually fairly understandable. So the second loop here is actually what we call the Synology loop here. In a way, knowledge and the memory, in a way, are kind of similar things. You can think about the memory as just short-term knowledge, and the knowledge is actually long-term memory. It's the one way to really think about that. And you have a model, you say you continue to accumulate a lot of knowledge. Let's say a knowledge about, say, UC Berkeley. And UC Berkeley continues to do really great. And Dave keeps reminding me that the system group here has been #1 in the country almost forever. And hopefully that will never change. And then you have this long-term memory for sure. So all these kind of things you accumulate. You accumulate this thing, and you try to apply that back to your intent model. And eventually you do the right things for the user. So these are actually 2 main loops here. Then you actually try to design. And eventually you put together the kind of Bayesian framework and try to do the optimization right. But you do have an out loop that I don't have time to really explain is actually what about you design different features. You have different features, then you actually feedback and do this whole thing. So I want to quickly take you through some of the real examples how we actually do those things. In the middle is really the intended knowledge, and in the outside is really the interaction or different kind of dialogue. You have the query level dialogue, document level dialogue, page level, even session level dialogue. And then you have the intended knowledge to really govern the overall how you think about this. Let me show you a very simple example here. Let's say you type a query called dem arrays. And we have a colleague, his name is dem arrays. And then you say, well, this query box here is where you formulate your query here. And this is a suggestion, what we call the Autosuggest. So this is where you associate your intent. You confirm or disambiguate or refer to those kind of intents. If you type then M-A-R-A-N, then you have all those things. It's actually coming from mostly the query logs that we accumulated over many years. Then you say, well, you have those kind of lexical suggestion here, say, dem rental. People actually just typed that, and we just give back to the user. Or you can type here, say, well, we happen to know some people, the name is actually dem arrays. So now with the arrow here, we can actually even suggest that, which dem arrays you actually are looking for. There are different people, with the same name, very, very easy, very simple examples here. And my team, they actually often use my name as a very good debugging query, because over the last few years, there's another Harry Shum, and unfortunately for me, becoming so famous, and the Harry Shum Jr., and I'm sure has some fans in Berkeley as well, especially young kids. So, or you could go to even Dan Marino. Sometimes people mistype. Dan Marin, and it's really mean Dan Marine. So you can also disambiguate. So that's actually one example there. And you can look at another example. Say, what if you actually mistyped in the UC Berkeley OSCE, and the Berkeley is mistyped? then that's okay. The search engine actually has the ability to really, really identify, this thing here. Say, well, you really mean L-E-Y, not L-Y, at the end of Berkeley. And we recognize that, and so confidently, we even serve an entity page on the right-hand side, say, well, the OSCE, that's probably the OSCE you're looking for. And you can even go beyond that, say, for certain queries where you have a lot of semantic knowledge, like a camera. You say, well, if you someone type a camera, the intent is becoming, more and more clear if you can actually suggest certain attributes of camera here. Say, well, camera in categories, brands, and megapixels. And so you can disambiguate with those categories. And you can even have some possible intents. Well, it could mean digital camera, or it even could mean camcorders. And you can refine the top intent by those parameters or facets. And for some of you who have been trying Facebook graph search recently, there's some very similar ideas. There's guided search, with different facets. So you can also have this lexical query log-based intent here as well. What if you actually select to say, well, I actually would like to try this camera on Nikon. You go to camera on Nikon, then you have more and more those semantic suggests with the meanings here. What if you say, well, I'd like to look for the cameras with the 14.2 megapixel. Then you say, boom, it will take you to a page. Now, it's not only just queries, but also have pages. And then you can do page level filtering and refinements. But the challenge for this kind of user interface is that you really need a lot of data for this kind of structured data. Otherwise, you cannot really go down too many levels. And as soon as you get into structured data search, very soon you hit this very difficult problem called data sparsity. It doesn't really matter how many billions of entities and the queries and the structured data you have. And as soon as you have a few dimensions, and you will have the problem, the problem of the curse of dimensionality. So we can actually go beyond the query and the documents, really get into those entities. And we really need to build the deeper and the deeper understanding about the user tasks. So the way really to get there is actually approximation, at least at this point that the entire industry is going after, is really try to get some entities right. I think you often hear from different companies to claim that have hundreds of millions of entities. And of course, if you think about a company like Facebook, at least they have minimal, a billion entities, because they have those names, if not more. And when we talk about entities, it's really about people, places, things, those physical things. So we start with those entities, then we also have the relationship between those entities. So you can really build an entity graph, and then you have those entities, the nodes, and the relationship as edges. And then with this, we can actually enable the user task completion to go beyond that. We have those, entities relationship. Then we can actually build those graphs to eventually go after certain tasks. And at this point, I would say that most of the tasks are associated with those entities. And it's not starting with the verb, then we go to the nouns. It's really mostly started from the noun and go after those verbs. But things actually change very, very quickly as we speak. So one framework that we actually feel is really the right thing to do at this point as we building the current generation of search engine, and that is also reflected with our user interface, is really going beyond the traditional, say, the mathematically what you really want is actually given a query you want to find these documents. Or I kind of lied. Actually, I have two pages with equations, but you can ignore the equation pretty easily, and the picture really says all. And now you move on to say, well, given a query, what you really want is actually not only the document, but also the entities. And you really want to do the joint optimization to get it right. The entity here really is a proxy to the intent that what the user really is looking for. And it's approximation at this point. It's really difficult to dialogue with the user, and once you get a few words in the query, and you're kind of guessing that, say, if you say, well, Michael Jordan, Berkeley, did you really mean that is actually Professor Michael Jordan of machine learning here in Berkeley? So all these kind of things. So I will show you, one example, starting with Professor Michael Jordan. So if you type Michael Jordan to any search engine, then you have beautiful, pictures and all those things with basketball. And that's, because there's one particular Michael Jordan basketball player is really, really famous. But if you're really looking for, say, Michael Jordan Berkeley, not only you have all those documents right, now you also get Professor Michael Jordan here. And also say, well, if you search for Professor Michael Jordan, and you also search for some people related to Professor Michael Jordan. And for example, the second person, Andrew, he actually was the student here, who studied under Professor Jordan here. And there are other people, Jeff Hinton and others, also in the related fields. People who just happen to search for those people as well. And after they search for Professor Michael Jordan. So that's actually very, very interesting things. And we can surface this kind of relationship there. Now, if you actually try a different query, then you say, well, Andrew, academic advisor, and we actually have the knowledge today, then we actually highlight and the Professor Michael Jordan will get what you are looking for. And it's not only just Andrew, it's actually, you are looking for, Professor Jordan. So here's another example. Say if you look for Barack Obama, and we say, well, people who actually also looked for not only Barack Obama, looked for Mitt Romney, at least recently, and Michelle Obama, and President Bush, and President Clinton. And if you mouse over to Mitt Romney, Bing will tell you that Barack Obama defeated Mitt Romney in the election last year. So you actually have this kind of edge information between those nodes and in the knowledge graph. So the more and more you can see this kind of information there, you can leverage and learn more what's really going on. So not only we can apply this framework that the query document entity for the document retrieval, and you can imagine that we can also do very similar things for images. You can imagine that people type Paul Allen Microsoft, Paul Allen Seattle, and they are looking for very much the same Paul Allen. And we can use this kind of framework to rule out a lot of other Paul Allens. They are really not the Paul Allen you are looking for. And so we can do a lot of offline training to really get this kind of thing right. And we get this entity, we also get this kind of more accurate images. If you look at that, try, I don't know, Nicholas Grace. And there are a lot of pictures and related to Nicholas Grace, because by and large, until now, we actually retrieve images predominantly using the textual image, text information in the surrounding images. But if you actually use what I talked in the previous slides, and you can actually get Nicholas Grace and really more like the Nicholas Grace you're looking for. And with a lot of computer vision people in the audience, you might even argue, why don't you use the content-based retrieval techniques that at least you say, well, those people look like a woman. They're probably not really Nicholas here. And there are different ways to approach this problem. And we're not ruling out the content-based approach at all. I'm just saying that there are other ways, probably more straightforward ways to get those things right. So this is actually the image search result. I also strongly encourage you to try our image search results and also have a comparison and make your own conclusions whether you should give Bing image search more tries. So there are a lot of challenges that as we think about this dialogue model, particularly as we continue move on from the document-centric experience to entity-centric experience, there are three areas in particular I want to call out. It's very, very difficult to do. Hopefully, a lot of Berkeley students will be interested in joining us either as a summer interns or the full-time employees to tackle those problems. It will be many, many years. I think your job security will be guaranteed. So it's just very difficult to do. Starting with the relevance, I think why Andrew, academic advisor, you are so confident that Professor Michael Jordan is the right one, and because of what? The relevance itself continues to be the huge challenge. The data quality is another very, very difficult problem, and I visited Stanford not too long ago, and I showed very similar results there, and talking about the entity graph, the difficulty of constructing that. There's a good example called the Bob West. And the Bob West results that if you look at the Google result there, and they have the wrong picture of Bob West, and for that particular entertainer, Bob West. And the Stanford professor told me that picture was wrong. I said, how did you know? Well, he said, because this picture is actually a picture of Bob West of my department. I said, really? But still, how do you know this picture is the wrong picture? Then he laughed and he said, because I took that picture. So he was so sure that the picture there was wrong and Bob West. So it's a lot of difficult problems. It's not clear how you can systematically and using algorithms mostly, really just continue to improve the data quality. And finally, I would say, user experience itself, continues to be a challenge. I think we're so comfortable with 10 blue links and the documents in the last 15 years, should I say, in the search engine. We get very used to. Now, with the entities and the other things, and how should we really think about the user experience? How can we design the product so that the users actually enjoy using the product? The key thing I have learned is that in the end, the search engine worked. And of course, the clever algorithms, millions of servers working behind the scene, all these things are necessary. But the key why search engines worked really is because people like us helped. It's really the user participation. The users actually are willing to give the information to the search engine. And we actually really using the human computing power to help improving search engine, most notably nowadays, because of the clicks. And so you can actually really do that. I think user experience continues to be the challenge here. So I'm running out of time. Let me just conclude my talk to say that search is a long-term commitment. And the core experience will be the most important thing that we continue to push. Starting with the search quality and the relevance, I think we after many years now, Bing is at a point that I think search engine is becoming more and more usable, and hopefully you agree with me. But the next step is really about the task completion. How can we help the user not only get the document, but more and more get the intent, starting with the entity and beyond. Then I would say we actually have defined this new Bing information architecture, and I actually don't have time to talk to you. I just do a very brief advertisement here. If you use Bing today, and if you logged on Facebook, and you actually will see on the right-hand side, you actually see some of what we call the social results, and your friends actually know. And if you type in the Oscar 2013, and some of your friends probably just posted something about Oscar a few days ago. And all those things, we have what the web knows, what Bing knows, and what your friends know. So that's actually the new direction that we're actually pushing forward. And finally, I would say, we have this dialogue model here, and that actually gives us the overall guidance and the framework, how we actually do the end-to-end integration of the intent and the the interaction, and bring everything together. And hopefully, I have a chance to show you more in the future, and I hope you can try Bing and more from now on. And send me your queries if you are not satisfied, or if you are satisfied, and especially compared with our competitor. And I guarantee you that I will give it a try and debug it for you. So I should just stop here, and hopefully we'll still have a little time for a couple of questions. Thank you.
Ram Ramakela, School of Information here. I have a question for you. The question is, you had a nice framework with the control feedback framework, right? So let me ask you a question and framework. So if you think of relevance feedback and active learning, they're all control mechanisms. So if you think of what you're describing as a reinforcement learning problem, the whole issue in the intent seems to be disambiguating the state space and adding the web and friends and so on. You're somehow, in using ontologies, you're actually using a more disaggregated notion of the state space. So can you talk a little bit about that, since you give such a nice talk? It's nice to flesh it out.
Yeah, I don't know how much I can really elaborate here, but let me just say, agree with you that your observation is right on. And I'm a huge fan of feedback theory and control theory. And part of my training in my undergraduate and my first master's was really in control theory. And I think, if you look at the human knowledges we have accumulated, I think feedback theory is probably among one of the most useful things. We do study H infinity and other things, but I would say in the end, simple PID really works. And so the challenge for us to apply this thing, as you rightly noticed, it's nice framework, and as you practice, And you have a lot of constraints there. And a lot of constraints say, how did you really, discretize the space? In a way, you actually know some of those ontologies, so to speak. And the way we actually do that until now is really we look at the entity space where we actually accumulate a lot of knowledge. Take the example, say, Professor Michael Jordan. So Professor Michael Jordan is actually one of several hundred millions of entities that we have. So at least we say for most of the queries, if we are so confident that there are some entities that can hit, and then we actually apply this particular model. But even with that, in that state space, and then for typical entity in our representation, we actually have hundreds of attributes or parameters. Then you say which ones should you surface? Should you surface the edge? And should we surface, say, the workplace and all other things, the awards and all those kind of things? And it turns out to be that itself is also a feedback problem. You come up with a few, and you roll it out. You see if people really click, and then you rotate and you do other things.
Back here.
Yeah.
Hi,
Yes.
I'm Supada. So you talked a little bit about people using Google as a habit. What strategies are you going to take to convert Google users to regular Bing users?
Wow, that's a billion-dollar question. And I'm actually coming here to learn from Dean Sastry, hopefully. But he didn't tell me anything because he's a classmate with Eric Schmidt. And I understand that Schmidt just came here recently and received his very well-deserved alumni award. And but Dean didn't tell me anything, and so I was actually disappointed. Maybe students can tell me more. What can I do so you actually switch? And it's really not a good habit to smoke. You got to realize. And I really hope that I kind of give this leave this message in your minds, and you go home. And it's really hard. And there are a couple of things that we try. And I think the one thing is actually convenience search. I think the fact that the big websites like MSN or Yahoo still have fairly significant search traffic, I think it's really convenience. So you go there, it's just convenience. And the search quality is getting to be good enough that like Yahoo, it's really Bing results. So it's actually pretty good. So that's really one thing. The other thing is you just have to change the overall user experience. And it's really hard. You also want to be a little careful because people have been trained in how they actually want to use search engine. We have some good ideas, and the brand new user experience, and hopefully, in not too distant future, we can share with you. But I'd love to hear your ideas. Yeah.
My name is Tae-Sun Moon. So I think most of the query examples that you gave are quite popular queries, like people's name and or like product names. But I think also the important part of the queries are the tail queries, where it's very hard to build like entities. It's like question and answer, this kind of thing. And I think that also really impacts like the habit of people using the search engine. So what are your ideas of improving those?
So that's a very good question. And so I actually have quite a few examples here. I don't have time to show you. So there are a lot of things that motivating us. What's the next? And exactly as you were saying, what about somewhat more tail-ish queries? And I don't know, is this tail enough? Longest river in Ireland, and probably it is. I would think it probably is the longest river in Ireland. You can compare some of those queries, compare Bing and Google, and have your own conclusion of what's really going on. And so it turns out that if you look at those rivers, and there are a lot of ambiguities, and I'm sure Dean Sastry knows this. For example, the longest river in India turns out to be very ambiguous. It's actually longest river running through India or longest river inside India. So that's actually very different. So sometimes it's actually very difficult to do. And you got to realize as we move to entity kind of experience, from the traditional document-centric experiences, in the document thing, basically saying, you know what, we'll give you some document. Good luck with you. Go click on the Wikipedia and other thing, figure it out. And but as soon as you pop up here, say it's actually River Shannon, and you better be, I don't know, 99% sure that is the thing. And especially for those tail queries. Yeah.
I have a question about evaluation. So typically, search is being evaluated based on,
very good question.
On relevance, but that's just a single dimension. And in your model, you want to go beyond that on multiple dimensions.
Yeah.
So the classical A/B testing or those kind of methods seems to me that might not work. So what are you doing to do that nowadays?
Well, I think you hit a very deep and difficult problem is actually how to evaluate the overall search quality. And there are really many different dimensions to really think about that. Let me take the simplest example. That is actually how did you evaluate the quality of those documents? That is probably the most well-studied in our industry. And how did you actually do that? And there are really two kinds of ways you evaluate such quality. It's what we call the offline and online. So the offline is basically using human judges. You have human judges say, look at this thing, and this is excellent, this is perfect, this is good, this is bad. And then you do some kind of accumulated score. And there are a lot of studies, there is a lot of literature, and typically we use something like DCG and or NDCG type of numbers. Then there's another thing you can do is actually the online metric. The online, the user can tell you a lot, especially in aggregate. And I mentioned about, say, if people click more. So for any of those queries, and for example, we actually have the data to show what's the percentage of the clicks. Say that 75% actually people clicked here, and 13% people clicked here, and all this kind of information. Not only you can have page level, this kind of online data, you can actually also accumulate it across sessions. And those things actually becoming very, very useful, yet can be pretty difficult to get this kind of data, and also is challenged to analyze. Another thing people do in our industry very well, in my opinion, is really make a science of its own, is actually what we call the A/B testing. So you have two designs. You have two different designs, and you roll out, and you really want to do the control versus treatment very, very carefully in a statistically non-biased way. And then you show which one really, I give you a very interesting example of this. So how big the search box should be. Small, big, the sweet spot, it's very interesting. Yeah, it's a hard problem. I actually think that is the most important thing is actually defining the metrics that you can evaluate your product. And what I do typically with every feature team, every team of mine, and I typically, when I review those guys' work, I typically ask them, and who has the highest IQ in this team? Then I say, you should work on metrics. Yeah, so. Okay.
Okay, let's see. This concludes our view from the top. So please join me in thanking Harry for joining us today. It was a wonderful talk.
Thank you very much. Thank you.
And we're delighted, Svi is delighted to present to you the small token of appreciation, confirming your status as a Berkeley engineer.
Oh my goodness, it's a great honor for me, and I actually was not able to get into Berkeley, so I went to CMU. So, yeah, so thank you very much. Wear with pride.
Yeah. For co-sponsoring the event, and look forward to seeing you March 14th. One more thing for the cool lecture featuring Bill Sullivan of Agile. So thank you very much. Goodbye and go Bears.
Thank you.